All right, welcome back, everyone. This is the start of day 4, Thursday, June 10th. This is the Virtual Residency Workshop 2021 at the introductory, intermediate, and advanced levels. And I want to welcome you all to our early morning session. This is facilitating artificial intelligence, machine learning, deep learning. Our moderator is Devi Nayak from the University of Washington, Tacoma, and I'm going to turn the show over to Devi.
Thank you, Henry. Good morning, good afternoon, and wherever you are, and good evening. Thank you for joining us. And it's a great and honor to be part of this panel. And in the initial part of our panel contribution, which we are facilitating artificial intelligence and machine learning, and especially discussing on various. So the unofficial introduction will be, we'll introduce all of our panelists, then we'll go on discussion. And during this, if you have any question, please hold, because we will have a Q&A session at the end of the panel. And so let's get started. So I would go as I see in the screen. Fanny, would you please introduce yourself?
Sure, thank you. Thank you, Devi. So good morning, everybody. My name is Mariofana Milanova. I'm professor in computer science in University of Arkansas, Little Rock. I'm also graduate from many years ago with master degree in artificial intelligence, master degree in electrical engineering. And after that, my area of research is mostly computer vision, deep learning. I am NVIDIA ambassador and certified instructor. So if somebody has a questions about how to become ambassador or how to become instructor or developer, I will be happy to help. Thank you.
Thank you, Fanny. Thank you for the great introduction. Next, I'll switch to Kyle.
Hi, everyone. My name is Kyle Monahan. I'm at Tufts University. I'm kind of play two roles here. I'm a senior data science specialist and a lecturer at Tufts. So I bridge kind of data science workflows anywhere from edge computing to a personal laptop to scaling up to our high performance computing infrastructure. And I also teach data analytics, a few courses in data analytics. And I love applying machine learning models to solve interesting faculty research problems. I'm very happy to be here. I'm really passionate about this. And I'm excited for talking with our fellow panelists about these interesting questions. So thank you.
Thank you, Kyle. Great introduction. Next, I'll switch to Yang. Ying.
Yes, let me unmute myself. Thank you so much for this opportunity, and good morning, everybody from Florida. So I'm from University of Florida, Information Technology and Research Computing. My background is in high performance computing and parallel computing with the AI initiative happening at UF. So we recently established this AI support team at University of Florida. At Research Computing, and I'm currently the team lead for AI support. I'm super passionate about the AI research, AI support, and AI services. So we do a lot of AI training, AI research facilitation, and AI consulting. So I'm as well as am a NVIDIA ambassador and a certified instructor as well. So thank you.
Thank you, Yang. Next, I'll switch to Tamika Simon. Please introduce yourself.
Good morning, everyone. Thank you for this wonderful opportunity. Again, my name is Tamika Simeon. I am an assistant professor of chemistry at Dillard University, located in New Orleans, Louisiana. Since my tenure at Dillard, in the chemistry courses, I have infused machine learning and AI and data science in most of my courses, and also have encouraged the undergraduates to pursue summer schools and internships in this area. So I'm very passionate about this field and the many opportunities available to our students and also faculty members.
Thank you, Simon, and thank you for a great introduction. And lastly, Mohammed Tanash, would you please introduce yourself?
Thank you, Deveshri. So, thank you, Henry, as well, for having us in this panel. And my name is Mohammed Tanash. I am an HPC application specialist working at University of Nebraska, Lincoln, as well as I am a PhD candidate specializing in computer science, like HPC computer science, let's say, and machine learning as well at Kansas State University. I've been working at University of Nebraska, Lincoln for a year right now. But I worked before with, New Mexico State University and Kansas State University as working with the HPC Center over there as a graduate assistant. My main role, in the university, I'm working with the researchers, be specific install applications for the HPC cluster, and provided the cloud computing as well with the virtual machines. Also, helping researchers to do accelerate their work, solve their problems if they have any issues. As well as some part of the doing research out or training and outreach.
Thank you, Mohammed. It's a great introduction, and as I mentioned already, we'll be switching to our more main discussion. And the first question I would like to ask to all the panelists, and especially I would like to start with Ying, Ying, as we know that, when we are applying or talking about AI research, it may be easier for researchers for engineering and physical science disciplines to adopt AI method in their research, but they're very challenging for research for humanity or social science discipline. How do you address this challenge and reach out those researchers in your institution?
That is a great question. It's actually a lot of people at our campus ask that question as well. So just very quick introduction of the University of Florida's AI initiative, because that is really tightly associated with this question as well. So a year ago, in April, UF announced this campus-wide AI initiative and made AI the centerpiece of a major long-term initiative that is combining research infrastructure, research, and transformational approach to teaching curriculum. So the whole goal of this initiative is to make University of Florida a leader in AI research and development. Of course, above all, is to making sure every UF students develops a basic competency in AI, regardless of the field of the study. So probably some of you already heard that we have $70 million AI partnership with NVIDIA, and come with that, they donated this NVIDIA DGX SuperPod machine, which is the world's fastest AI supercomputer so far. So with this initiative, because it goes to every college, every departments. So we have received overwhelming interest in AI from every corner of the campus. Naturally, that question come up. So basically what we hear from those researchers, especially from humanities, social science, the basic questions are, what is AI? And then how can I apply AI in my research, and where to start? So for some engineering school faculty research groups or bioinformatics, they already have statistics background, and a lot of them already start AI research or apply AI in their research. However, from humanity, medical school, social science, arts, University of Florida is one of the largest college at the US. So it just have every type of disciplines on campus. So those researchers really has very limited knowledge about AI, not to mention how to apply AI in their research. So for this first question, what is AI? The key is training. So research computing and our AI support team had, during the past year, we provided a lot of training sessions on various AI topics, mostly at the intro level. So we partner with NVIDIA and already hold 6 or 7 NVIDIA Deep Learning Institute workshops at the UF. They are extremely popular. And we also provide short bird of feather session, like almost every Tuesday at the noontime to show our users how to conduct AI research on our supercomputer, basically Hypergator, that's the name. And that is a great way to get their feedback, their questions, their needs. I think it's the both sessions are really short. It's not meant to be training, but it's basically two-way street. So we show them how to do things on Hypergator. We get their feedback and also great feedback to improve our AI support services. So, and also our training team did a fabulous job in designing training materials, especially targeted at faculty and the students who have very little knowledge about AI. And some probably have very minimal level of skill set in programming. And for the second question, how can I apply AI in my research? So that is most question hanging on our PI's faculty's head. So what we do is, so in the past year since the AI initiative, we had 2 AI focused symposiums, one last fall and another one this spring. So we invite faculty from different research disciplines who use AI in their research to present their work at those symposiums and to show how they apply AI in their research. So, and during those symposiums, we set up breakout rooms with different research focus so that people with the same interest, they can discuss, exchange their experience, their projects, and also a great way to find the collaborators in their interest of areas. So
that's really,
yeah.
Ying, that's really a great advice for especially faculties and researchers who are from social science background. And I do have both science and social science and technology background, which I can see that when we talk about, like you mentioned already, that, when artificial intelligence and people always ask question, where can I start? And especially like, not technology, like social science professors and researchers and faculties, like where when we start? Well, artificial intelligence is our day-to-day part of our life. So we are doing email services, which is also an automated system. It's an example of artificial intelligence. So learning about like how we can acquainted with, we are using phone and there's a lot of applications, and that's also a robot in our home when we are cleaning. Nowadays, everybody has that. So artificial intelligence is our part of day-to-day life. If we can become familiar with that, and that's how reduces our anxiety that, we don't know what is AI. It's only the computing world rather than it's very diverse world. That's great insight. I would like to get Simon's, what's your thought on artificial intelligence when we talk about how social science faculties get involved in research?
I think in terms of getting social sciences and participation in it comes from a cross-disciplinary approach. So for me, at a primarily undergraduate institution where we have limited faculty and limited faculty in terms of like the access to resources and also also sometimes it's kind of difficult for us to collaborate on different topics. So what we could possibly do is have a cross-disciplinary approach to data science and AI and try to see if we could collaborate on courses such as selected topics or special topics. So students in humanities can understand how chemistry is related to their field and also vice versa.
That's a great approach. And in cybersecurity, when we talk about artificial intelligence as well in computing, high performance computing as well, it's always like cross-disciplinary nowadays. Everybody is talking about that, how we can contribute in, to make the world a better place, and especially AI related. I would love to have thoughts, Mohammed, what's your, because you are working in high performance computing, how, when we talk about this question related, that like, it's very challenging for humanities and social science discipline when we talk about AI research, and how do we address those to reach out those researchers in your institution, especially?
Yeah, sure. Like I'll give you like an idea of something. It's like it's really hard right now and like these days to separate, for example, computer science from other majors. They are all combined together. And that's why like most of the university right now, even in the PhD level, they have, like subspecialties for their, majors. On the other hand, like in the PhD, there's like interdisciplinary work or interdisciplinary PhD, which is, combined like mostly computer science with, with their major. So, and as we can see it, like in any HPC center, you can see most of the users, they came from like disciplines different than computer science. And that means they need the resources and they need to do the research using computer science techniques. Most of them, there's lots of them, like they need like machine learning, AI or like deep learning. It's like, it's really hard to, distinguish because they are like the same topic or same field, AI, machine learning, and, deep learning. While like it's really hard problem, like this is like a knowledge. So when you give like a group of people like a knowledge, that can't come like in 1 day or 2 days or even a week. You can give them a general idea of, for example, what's machine learning, how we can use machine learning, but like in deep, like the understanding the techniques, it needs time. And like from my opinion, if there is someone from like a major like different than computer science, or they don't have knowledge about AI, machine learning, and deep learning, it's not good for them, for the researchers, to do research that they don't know about. And like my first suggestion, if you are doing a research or you want like deep learning, machine learning, or AI, because they are like really heavy topics, it's not like an small topics or like introductory topics. They are like deep topics in computer science. So my first suggest for them is, if you don't have knowledge, idea about like these topics, I suggested you to go and take 1 or 2 courses. So in this case, like we offer some courses in the computer collaboration between our collaboration between our center and the computer science department, because we are just part of it. So we offer like different kind of courses for machine learning and AI. I would rather, as a researcher, to take a course and spend 1 semester learning about AI, machine learning, rather than dive in and don't understand what I'm doing. So it's like 2 ways. Like even you can treat AI and machine learning as a black box, or you can treat it as a white box. It depends on like what you want to use from, you know, those fields. On the other hand, like sometimes like they need a very specific, you know, topics or courses. In this case, there's like many online, you know, courses that offers, you know, like from like different, you know, institutions. I don't want to, you know, like call a specific one, but like there is many we can suggest for them. On the other hand, like there is also, we offer like, you know, like a one-to-one meeting. And those meetings, you know, we will address the issue, we will listen to them, you know, and decide what they need probably, like, because sometimes like they have a problem but they don't know what to use. Like, should I use like machine learning, should I use like deep learning, or should I use like maybe neural networks? I don't know. Sometimes none of them will work for them, right? So first of all, like meet the researchers, give their idea, get their feedback, and then after that suggest some best solutions for them, either like by taking courses, or for example, by, you know, maybe we can suggest some like courses from the department or some departments in the at UNL, or maybe at the end, maybe, you know, suggest some specific solutions for their you know, research.
Also, like cross-disciplinary, when you mentioned that, and I also like to add to that, and I completely agree with you, like Mohammed, also attend such kind of events if you don't have an idea, virtual residency, and, you know, become an ambassador, and or like, you know, having, you know, part of the community, reach out to other faculties and say like, hey, can you give me a brief descriptions and what I'm looking for, and this is what I'm looking for. Fanny, do you have any additional things to add to this question?
Yeah, I would like to say that I always give the advice for people that are not experts in AI to start with the problem that they like, something that is interesting for them, you know, and start from small, resolving small problem, because otherwise it's so confusing. So for example, they want chatbot, they use chatbot. Let's understand what the chatbot is doing. And like Mohammed mentioned and Professor Zhang, so there are so many facilities and courses. I like the idea that they can start with small problem, go deeper, understand, learn the courses, and move to next topic, you know, so because it's challenging.
Yes, it is really challenging. Thank you, Fanny. Kyle, do you have any other perspective, given that what our other panelist has been speaking, because you actually worked both in teaching analytics and also, like, you know, working as a specialist as well?
Sure. So similar to what Fanny mentioned, I like to get people excited first, because the faculty tends to be the expert about their data. And a lot of times they have a data set or a problem that they ran into and maybe they couldn't solve with traditional computing methods. So the first thing I do is I find a research question or a data set that is interesting to them. And similar to what Fanny was saying, that's really engaging, something we can solve, a quick win. And I say, all right, let's do this together. This is kind of our test case. From there, that's when the trainings that Ying and Mohammed and Tamika all mentioned, right, come in. Because if the faculty wants to continue, it might be more challenging computationally. And there is this danger, as Mohammed mentioned, of deploying a model that's incorrect. I think we've all seen, you know, a model that we think is doing one thing and it's been deployed, and maybe they're in final preprint in the paper, and then you find, well, you know, those hyperparameters, you didn't exactly do that right. So maybe we need to revisit that. And so to prevent that from happening, I always think training and working with the faculty after we get to that sort of toy or interesting model phase can be really useful. I always try to keep that excitement though, because it is such an exciting field. And I think keeping that lets me be more motivated, lets the other faculty I work with be more motivated, and it can be useful overall. I think a great point that the team mentioned here was around collaboration. One of the things I find is, because we support so many faculty in these roles, there's a lot of faculty using our computing infrastructure, it can be nicer to have collaboration with computer science faculty and their graduate students working on projects, just to enable projects to keep moving forward. So I love the idea of learning from each other and kind of collaborating in that way. I always try to enable that where I can. So.
Thank you. That's a great perspective. And additionally, also, I would like to add to that is that when, we are talking about data sets, and there are many times questions are like, where can we get the data set? There is Kaggle data sets you can literally download, which is publicly available. GitHub is a great resource. Google Scholar and Google Research and Google Data also available. And people can find folks who are social science, especially criminology, psychology. There is ISP Square, and there is public data is available in, you can go to the county website or federal website where you can literally, there is data sources, and CIA database is like also publicly available. There are many data sources where we can download in the form of various form of like Excel and SPSS and any other form you want, and then have play around in training data sets. That's how you can have data sets and have knowledge and enhanced and ask questions. That's being said, our next question, I would like to start with Kyle. And especially this is like a combination of Mohammed and Kyle. Kyle, I would love to open to this question, is that how do you guide researchers who may not actually need deep learning, but where a classical model approach would apply, and any tips and tricks getting researchers started with the deep learning, with the high performance computer? And like, again, that's how I would like, both like Kyle and Mohammed, that using graphical processing units, and especially GPU, which is very famously known as that, how do we enable researchers to learn, deploy these models? Any thoughts? I would love to start with Kyle.
So I think in terms of GPUs, my favorite way to get people started is actually Google Collaboratory. And for those who might not have used it, it's an online platform run by Google. So, pros and cons there, but it's a really great platform. I think they have both GPUs, graphical processing units, and TPUs, so TensorFlow processing units. So because it separates the user from the hardware level and the need to think about, well, what machine am I on? Are the kernels correct? Do I have all my Python libraries installed? Google kind of does that for you. The nice thing is I can share a link to a Google Colab notebook and have someone up and running with the classic MNIST digit recognition problem in 2 minutes. Right, and showing them a wide variety of different approaches. I have a series of notebooks that I always provide for faculty, and as we work together, we get more examples. From there, building on that, we might move into libraries in Python for implementation that we can compare modeling approaches that are using more traditional modeling work versus deep learning modeling work. So I like to sometimes say, let's take the most classic model, like a logistic regression, and compare that to a deep learning approach. And if we see, well, they work pretty similarly, except this one took much longer to run and we don't really gain any benefit, then they'll see, where that can be useful. On the contrapositive, you can also see areas where it would be very useful to have a similar machine learning or deep learning in some cases model. And so I think the focus on GPUs for me and enabling uses of those GPUs and showing people how powerful GPUs and their floating point precision can be, it's a really useful way. And I always start with Google Colab and then kind of scale up from there. Mohammed, you might want to add in some more though.
Absolutely. I totally agree with you, Kyle. So this is really a good question, and I think it's important because, as you can see, like we faced a lot of researchers. They will come to you and they will say, I want to use machine learning. Okay, I want to use deep learning. So what's the difference between machine learning and deep learning? This is a very important to distinguish between. And like many people, they don't know, is it like, actually, you can see AI is the bigger bubble. It's inside of it machine learning, inside of it like deep learning. They are like, they are almost the same. They have some differentiation about their purpose. So first of all, like for myself, I would love to, listen to the researcher and see their data. And after that, try to help them to specify which techniques in machine learning or deep learning is, appropriate for their, for their problem. For example, I'll give you an example. Like there is like, for example, if their data, for example, have lots of labeled data and big labeled data, that means like deep learning is a good approach for them. Even though like, like as you can see, like some of the examples like deep learning that use mostly, they are, concerned about like text data, images data. And, like, for example, they used it for detecting like autonomous cars or, like, for example, like detecting cancer cells in the medical field, or, detecting pedestrians for, like in the traffic, something like that. Like if their problem goes to that way, I would, and they have labeled data, they have a very, good amount of labeled data, then I would, guide them to use, deep learning. While if they are, using just, they have a normal, like, text data, and they want to do, for example, classification, or they want to do a regression or, clustering, then in this case, I will, guide them to use like machine learning. On the other hand, GPU versus CPUs, there is like many of the, like, they don't know what's the difference. Many of the HPC users, they will come to you and will say, I want to use GPU. Like I requested for 5 GPUs or like 100 CPUs. Is it this the appropriate, hardware for your research or for your algorithm that you want to implement? It depends. Then this is another, opening question that we need to dive into their, their tools they are using, or the data, or the goal of their research. For example, for the deep learning, because we are using lots of images, I will guide them, like we offer GPUs and it's going to be much more, faster than using CPUs, while, using normal processing data, probably like CPU bound more than, GPU bound. And in this case, like I will guide them to use like CPUs. So the goal here is, understand the problem, help the researchers to understand their needs for the computational, needs for their research and to solve their problem.
That's actually a great insight that, like, help researchers to understand the problem, and being a researcher to find out the more clarity of the problem is like, we can download the data set and trying to find out like, this is the problem we had, and the larger, as you mentioned, and Kyle, you mentioned that is the collaboration and the collab platform, Google Colab platform. Also, it also not only like the Colab platform having knowledge, also having knowledge in programming, such as Python, by using Python libraries and C language or different languages which you can incorporate with. And then folks who are doing research in psychology, like cognitive psychology approach to train in a proper way, diverse group, diversity team. We're talking about like, very much, it's very, very important that the time has, the team has to be very diverse, else will end up creating a product in artificial intelligence which will be only applied to specific people. And that's being said, it's a great insight, and I would like to follow up if any other panelists have any thoughts to add on this.
I can add some comments and the experience. So I think the question has 2 parts. One is machine learning or deep learning, and then GPU or CPU. So machine learning, deep learning, I think I agree with all the panelists speak so far. I think they are all really case dependent. So for us, we do provide the consulting. So I think machine learning or deep learning, like a lot of our existing professors or researchers have like a classic way hand designed machine learning algorithms to do a lot of data analysis, and how to engage them, and to see if it's possible to use modern deep learning methods. For example, like natural language processing, you can use traditional decision trees and random forests, or other type of traditional machine learning methods. or you can use the newer deep learning like NLP methods, transformers, and things. So I think it needs a little bit training time and refer, for example, present them some papers, and we give them some advice. And sometimes if people from like a social science, English department or communications, they do have a needs for the NLP, natural language processing. We bridge them with certain other professors who specialize in NLP and get them to in the same room to discuss the approach. And in terms of the, so that's one way. I think there are lots of use cases for CPU and the GPU. And I think we at the UF, we have our own cluster. So we encourage our users to use all our resource. So I think there's one really nice tools. Of course, they're all popular like TensorFlow and PyTorch. We all made it available on HyperGator. However, I think NVIDIA does have this NVIDIA Cloud. I think some of the audience probably have heard of that. It's really it's all like a container based all applications. So it's very self-contained, and we can it's easy way to use them to on the GPUs. So
and also like when we are talking about NLP, we also like, you know, we have very diverse group of panelists today who speak different types of languages, and those natural language processing and artificial intelligence, as we see that like if we provide any kind of like live transcript and kind of translation of different languages, it kind of helps us to understand. And that's also like a component of artificial intelligence and machine learning, that how we train the particular software to translate. Not exactly, I won't recommend that Google translation in a particular way that it will literally give you a different meaning, but it kind of helps somewhere. And that's being said, I would love to like ask, and this is it's like two questions, and I love to start with both like Fanny and Simon, that so there is two questions to this, is that that what are some strategies like four-year college and universities can implement to ensure that their graduates are prepared basically for emerging technologies and graduate programs in AI especially and machine learning? And also, what are the new challenges when we talk about like, you know, responsible for the trustworthy AI? I know it's a two-part, but I would love to start with Simone, that how can undergraduate universities will prepare, followed by Fanny.
So some strategies that come to mind, or one strategy that comes to mind, is that like four-year universities such as Dillard University should come up with an action plan. And the action plan can have like a supply side and also a demand side. And so the supply side deals with the near-term readiness of preparing our graduates. And then also it deals with in terms of what actually do they need? How do we prepare them? So some ideas that come to mind or some strategies is one, encouraging our undergraduate students to pursue internships, REUs in data science, machine learning, and AI. Also encouraging as an institution for faculty, students, and instructors to participate in boot camps, short courses, and also summer schools. And also think about like how we can take other models of summer schools that have been done, such as at the Atlanta University Center, and try to, you know, think about how we can do that for our region or our state where we have other HBCUs in the area. Another strategy we could do is also a lot of times some faculty, since this is not AI and machine learning is not new, but some faculty members may be afraid to pursue this, right? So that could be a barrier in terms of demand. So also encouraging the faculty members to attend some type of short courses as well. And also getting administrators on board in terms of understanding the importance of AI and data science in infusing it in most majors at Dillard.
That's great. And you actually raised a very valid point that collaboration with HBCU, with historical Black colleges and with the minorities communities. And many times we get overwhelmed that what to start, where to start, do I have enough resources? I don't have proper fundings. And being a researcher, being a graduate student or undergrad who is coming from a poor or underprivileged resources and life and different family background and different walks of life, as we all are coming from different walks of life, it's very, very important that going through boot camps and going through attending virtual residency programs and short courses, asking to the community, put it out there that you are interested, and that will be. I would switch on to Fanny that when we talk about trust AI, what are the AI challenges, comes to your mind when we're talking about artificial intelligence?
Okay, so first, we understand, all of us here and the participants, the challenge of AI. And I know I want to thank you, Henry, for creating this panel. So I have a long years of experience, and I know when people are excited about neural network in 1989, and after that forget about this. They are excited about support vector machine, and now they forget about this. Now they are excited about deep learning, and everybody wants to resolve the problem with deep learning. But I will say that for the conversation that we have before, they realize, they think that it's a magic box, and oh my goodness, we will do whatever we want without to put any efforts, and the models exist. And they realize that actually they need a machine learning and AI knowledge. And now all of these new models are modified. And the problems are many right now. So what I want to say, I don't want to see that this excitement will die, okay? And this is why I say thank you for everybody that participates in this panel and everybody from the audience, because I really want to see the progress, not something that people don't trust. So, for example, there is an article, and many articles actually. This is why I go to this direction of trust AI and explainable AI, because there are statistics that we teach our students and faculty, but when they go to job, the industry cannot recognize the knowledge of our students, okay? So we have to explain and collaborate not only with the faculties and students, but also with industry partners. So the trust AI is coming very significant, because the people are using recommendation of what kind of movie I can watch after watching such a movie. And this is okay. And recommendation system are fine. And natural language processing probably is fine. But we start be confused when start faking our face, or faking the situation, okay, deep fake face, or even a more extreme case when we have a telerobotics and surgery, okay? Can you trust the robot to do the surgery? So it's a problem of trust, really. And explainable AI, you need to explain not only to students, not only to faculty, but to whole society. the users. And the worst of this is, the worst or challenge, that this area is growing so fast, okay? So even for us, it's difficult to follow what is new. And we have to do in the same time teaching students, the same time doing the project, collaborative work, and explaining all of this to the society and convince the industry partner. So it's, yeah, I mean, this is why I want to say that we have a lot of work to do, okay, to educate the, in my classes, and what we do is project-based learning. I'm part of a coalition that is doing cybersecurity and AI certificate. So we're trying very closely to work with Homeland Security Agency. And like I say, the user of AI needs to be educated, the developer of AI needs to be educated, the partners agency. So I hope I answered the questions. Thank you.
Thank you, Fanny, and thank you, Emika, for having a perspective. And it is very, very important, as we mentioned, that we need to have a collaboration among researchers and faculties and industry. And having a class which will be a project-based learning and also combination of implementation, because it's easier to, like, when we go through lectures, and if there is no applied research in artificial intelligence, which is a very much like application oriented and kind of like understanding interest. And when we talk about like having machine learning to be trained, it has to be the machine learning, the artificial intelligence, the machine can be trustable. It has to be applied to diverse audience, not to be specific, because as I mentioned previously, that when the team is diverse, definitely the set of ideas, when we're teaching machine to be diverse, not only like one. And there are various examples we can see that where the artificial intelligence system failed because it was only made for certain walks of people, not kind of very diverse. So inclusive, making the training inclusive, making the education inclusive, and diverse, it will be add. I would like to know any additional thoughts, if any of the panelists, to add to the, when we talk about trust with AI, starting with, I would love to listen, Yang, if you have any thoughts.
Thank you. Yes, actually, this is a great topic, and especially in this day and age. And we are actually paying lots of attention to inclusive AI, AI for all, and fair AI. So trying to raise awareness of this, all these issues in terms of the inclusiveness. You bring up a great point. Yes, we do a lot of training, and yes, when we talk to researchers as well, like data connection, you talked about a lot of the like reference data. So when we talk to our researchers, we always bring up the issue of the data bias, and because that is something is kind of intrinsic, or because it's all the data is connected by human. Anything conducted by human, I think there's always some underlying bias there. So how are you going to try to have connected data in more inclusive way to cover as many cases as possible? So we do, when we talk to our researchers, we always bring up this focus and this topic awareness. And we host a lot of reference data on our system as well. So we try to weed out all the very bad languages. And yes, it is a process for us. I think this is a great discussion point, I think, and on the campus as well. So we try to educate people and every opportunity, and our conversations with our PIs, especially for our facilitators. We are all facilitators. I think it's really education for all our students and the faculty. So, and raise the awareness. Yeah.
That's a great insight. And it's, as you mentioned, that like, removing the noise from the data and removing the bias, like it's possible that like, what type of things can be added, and understanding that whether we have like larger sample size, not like representation. When we have small amount of data, it doesn't represent. And that is always an issue when we talk about data, that what is the representation, how much data we are available, and what is the sample size, and how much male and female, and then that how much different representation of, is it gender inclusive, is it sex inclusive, or is it religion? There are so many categories when we talk about, and that is the really excitement, that there is no one answer to it. It's just that data is very much, when we collect it, we can see, and we can literally forecast our future, and data is everything. As we mentioned, like, Fanny mentioned that like she has been working, AI and security, cyber security aspects to it. So after all the discussion, we are literally like, for the final, I actually kept this question about cybersecurity, and everybody is talking about cybersecurity nowadays, and lot of attacks going on every day. New attack, Colonial Pipeline, meat industry was affected, ransomware attack, and people are paying ransom. Well, why people are paying ransom? We need to see. It's because of data, and because of the data, which is sensitive, vital, and when we talk about like impacted and various personal information. So my next question to all of us is that when we talk about data security is increasingly important, based on when we're talking about PII, which is personally identifiable information, especially when we talk about like GDPR, which is one of the strongest privacy laws in European Union. Now every state is following, for example, California Privacy Act. How do we enable faculty and staff applying AI on a shared data point of view, and to protect their data? And like, what can we do that AI to impact, to remove cyber attacks? I would love to start with Kyle.
I think this is always a challenge. I think thinking early, even before the data collection, if we can, right? Thinking about what the data management plan looks like, if you're a university or if you're in the private sector, thinking about where that data is going to come in, where it's going to store it, at what point does it get de-identified or anonymized? Is that storage going to change over time? Who has access to it? All these questions kind of need to be addressed super early on. Of course, this isn't always the case. A lot of times we might be brought in maybe after the data has already been collected, it's sitting on some stored drive, and we might have to work with it in a new way and think about how we're dealing with this data to protect it. And so I think if you have a cybersecurity group, it's great to work with them. If not, a lot of times you may have to learn some of those things on your own, depending on the size of your school or location. But yeah, I think getting in early and thinking about all those questions in advance, even at the grant application stage, I think would be the best case to do it if we can, and we can't always do it. But that would be my suggestion. I welcome any other comments though.
That's actually a great, and cybersecurity is my field as well in research, and I do research in that data governance and data security as well. The combination of finding out whether do you have a data governance program at your university, and finding out if you don't have, then start one. Do you have a data governance team who can literally channelize that? Because when we are talking about research and an organization and an institution, there are various component to it. And when we talk about, there is faculties, students, then employees, and then there is research, and then apart from that, and there is like student hub. So there are a lot of data which is personally identifiable data involved when we talk about universities. So need to have a data governance plan, how it is going to be. And the security is like what type of security is being used. What is your security program? As Kyle mentioned, that do you have a security team? If not, can you train folks who are from technology branch or even social science branch? Can we train them? Can we educate them so that are we selecting right people? Because when we talk about artificial intelligence, there is a human loop to it. So we need to make sure that right people will have the right access, so that it is not going to channelize to cyber criminals those data, or kind of many times identity theft is a huge problem when you talk about artificial intelligence. So those are the questions and needs to be asked right way. Mohammed, do you have any insight for when we talk about, AI in security? Because in research area is high performance computing. Oh, you're mute.
Okay. To be honest, like I'm not that close to the cybersecurity field, but like in our institution we don't have a specific group for cybersecurity, and it comes to the to the idea of like, for example, do we accept, for example, protected data, or like do we store some sensitive data in our clusters? So unfortunately we don't, because this is a big responsibility, and there is many consequences will happen if something somebody attack the system, or can steal or attack the data. So in my opinion, there's supposed to be, like, if you have like a data center, for example, that would be good, to have like a specific team that will be responsible for protecting the system in general and the data in specific. There is nothing 100% protected, as we can say. There is always some specific things that they can do, or they can attack, and you will be very unlucky if someone will be able to attack your system, or do something bad. So yeah, we have, for example, like a sysadmins team, which is responsible for most of the things on the system side. But unfortunately we don't, usually like data centers mostly they will be away from accepting storage for specific or
it's basically like what you're trying to mention that, and which is a great point, that you need to have a team, and apart from the team, we need to have a general awareness about artificial intelligence and cybersecurity, because as I mentioned from the beginning, and as we are all discussing, that we are somehow familiar with artificial intelligence. Many times we don't know. Again, we are all sending emails. We're all using some kind of applications. We're all using some kind of like small robots for our cleaning services. We are all using for our trash, like pick it up. Everything which we see automating is related to AI. And when we were talking about AI in cybersecurity, especially to understand that first there is a human look to it, making sure that right people will always have right access and confidential information when you are sharing. Second thing, also the background needs to be checked. There is another loop when we're talking about practicing security, secure coding, when we're talking about technology, having different libraries and having at least knowledge, and security by design. So if we add security to everything, security governance, data security by design to the data, computational, and when we're talking about physical security as well, I think that will give us artificial intelligence into cybersecurity, which is a huge topic of discussion nowadays. Funny, before we wrap up, we have a couple of minutes. Do you have any last thoughts when we talk about artificial intelligence?
On the topic cybersecurity, I just want to add that it's so multidisciplinary area. So when we talk about cybersecurity, we cover actually ethics, we cover law, we cover risk management. And the problem, we have this certificate workforce, okay, preparing people to add in the industry in cybersecurity, work in cybersecurity. So what we're trained them, it's all of these areas. But what I want to mention is that there are not enough data sets available. So people right now complain. So if you want to train people, you really need to have data sets for different kinds of attacks. And like I say, this is the very complicated multidisciplinary area.
Thank you.
But AI has a future there, definitely.
Yes. And definitely, like, regarding the data sets and stuff, there are some data set available, but when we talk about like clean data sets, it may not be, but there are like a lot of malware research and data has been collected and but there is a warning sign that if you're going to download this data for research purposes, there, as I mentioned, and as we all know that, practice security by design, security by training, the way it go. And it's such a multidisciplinary field when we talk about artificial intelligence, deep learning, machine learning, is that not only one discipline is enough. If I say, oh, computer science is only going to solve this problem, now we need psychologists, we need sociologists, we need mathematician, we need information science and businesses, everything together. So we are, time flies by. We're almost like, we have 15 minutes, which we will be opening now to a questionnaire session. Before we open to general questionnaire session, I would like to have all panelists to have any final thoughts. A couple of thoughts, if you have, after brief discussion, what are the takeaways you want our audience to take away? I will start with Simon. You are mute.
Okay. Well, some takeaways, primarily for people from like undergraduate institutions like myself, is to encourage, faculty members and students to attend sessions like this. And also, when you were talking about cybersecurity, I have a colleague that has been interested in it, and it's not my strong discipline, but since it's not my strong area, to encourage him and others by being an advocate to attend these workshops and pass along this information to them as well.
Thank you, Simon. That's a great insight. Next, I will go as screen displayed. Kyle, any final takeaways?
Sure. So I always love to enable excitement about deep learning and hope to allow people to train each other and train themselves, to kind of train the trainer approach. I think also thinking about every single person who's working with data as an arbiter of that data and of the ethics around that data, thinking of potential bias in models, trying to have this kind of agreement that when we're working with data, we are the arbiters of that data and the security of that data. And so trying to create an environment where we think like that as someone who's working with data. So those are my two things: enabling excitement and thinking about arbiters of data.
Thank you so much. Ying, do you have any final thoughts?
Yeah, just a couple of them. I think very important in AI in this day and age, multidiscipline and collaboration is the key. I think if you're working on AI projects, if we do not know where to start, looking around the campus, attend the talks, find somebody that you can collaborate. So I think that's very important. Another takeaway point is that if you are a student and looking forward to a career, something associated with AI, there are so many courses online everywhere, and the badge program certificates. I do encourage you to get those certificates. It's great to put on the resume. So our university provides certificates. I think that's a great career development.
Thank you, Yang. That's great to hear. Fanny, any last thoughts?
I want to say that AI is not in the movies or in the books. It's in our life. It's not iRobot. It's everywhere we mentioned. So, and I'm excited to live. And this time, in this fourth industrial revolution, is excited time to live and work. Okay, and I hope and wish that the progress will continue.
Thank you, Fanny. Definitely, the progress will continue.
And the young people are excited. I can see they are applying already this machine learning, artificial intelligence techniques in every aspect of their life.
Yes, and that's really great. Means like we all are excited, no matter where do we start and where we are at, and that's great. Mohammed, any final thoughts?
I would love actually to talk a little about having the trust AI. I really like the this sentence, trust AI. So like, trust, like there is not 100% trust. You will not reach 100% trust at all. But the thing is, like, trust comes from, experience and from like people when they try it and, day by day. It's like, do you trust to drive an autonomous car or you don't? So like people, they are afraid a little, then after that comes like day by day. And on the other hand, do we trust science? If you trust science, so we should trust AI as well. We are like, I want to mention that we are the ones who provide the power of AI and machine learnings by providing our data, in our, social life, and any action we do in our life, we provide, more capabilities to the AI and machine learning. The thing is, I suggest or recommend everybody to start and learn AI from now, as early as possible, because in one day in your life you will need it. So there's many resources you can go through and choose the best way for yourself.
Yes, you mentioned a very great point that like one day we'll need it, and we are actually needing it because we literally like all over the world is connected through different AI. Even if our messaging system, we are talking and internationally and connected through COVID and now as well. That's being said, my final takeaway is after all this discussion as a panelist, it's an honor to be here, is that reach out if you don't know, and deep dive wherever you are at. There is nothing like, today you will start, tomorrow you will start. Third thing is that there are a lot of resources available. Attend any kind of group like virtual residency program and join any kind of like meetup group, or you can say. And last but not the least, if you still anxious or there is a problem, you may be introvert, super introvert, and there are different personality people, especially researchers. Ask somebody, write an email. This community is great and they're very supportive, and that's how we will be like enhancing our knowledge. That's being said, we are open to question answer. If you have question, please post it in the chat. We will love to answer. If anyone has any type of questions, they would love to answer.
I just want to mention I really appreciated the discussion about de-identification. That struck a chord for me. I always like to ask what we mean by de-identification before someone opens up a data set and lets me take a look, just to make sure we're exactly on the same page. I'm sure many people can relate potentially, and it's always a good question about de-identification.
Yes. And before we get, and I think that maybe some people have questions, but I do also have to have question. And this question I would ask on behalf of my students, which been like asking that when we're talking about artificial intelligence and research, especially undergraduate, how to get started? Is there any resources any of our panelists can answer to go there and just get started?
So I will start here. So the thing is, like, as we know, there is a responsibility for the faculty, departments, and universities, community in general. So what I think is, like starting from the, because AI is a big field. So, and we can start from the high school, for example. So we can start from as early as possible, to teach people about AI and machine learning. On the other hand, in the university level, so it doesn't matter if your major is computer science or business or engineering. So providing some like courses related to the AI and machine learning is important because it's involved in any field right now. On the other hand, research doesn't mean you have to be a grad student to do research. it doesn't mean you have to be like a master students or PhD student to do, like publish papers or dive, inside any topic. So like, starting with, collaborate with undergrad students and involve them in research that will give them, very a good idea about how to be in the future or how to continue their research after the undergrad level.
I would like to add, Mohammed, that for example, companies, I'm familiar with Google. I have 2 of my students working in Google. So they hire actually high school students for internships. So they are going even to level high school students. And we organize events here for high school competitions, summer schools, and they are performing very well. So people, young people are excited and they go and learn AI. So yeah, so not only undergraduate, but high school students also participate in and
The
learn. Yeah.
That's a great point, as Fanny mentioned that, like, and Muhammad as well. I agree with all of you that when early intervention, as we said, like, when we trying to plant the seed early, it will become like, and then you take care of it and it become tree. And that philosophy applies here in artificial intelligence. If we want our next generation to be AI equipped and kind of understanding in various ways, and whether it's a conceptual way and in the ethics way, or we can talk about, like, ethics in technology, which one of the course I will be teaching at the University of Washington also, like, having those programs. And already, like, no matter your computer science, you can have information science, you can have social science, you can have, like, businesses, having those early intervention, having seek that as like cybersecurity, artificial intelligence and machine learning is the umbrella, and with different component to it. So there is not one component will make it AI, it's a machine. So it's like, like all of our panelists it's a great panel discussion. Only one person will be only speak only one point of view, not the various point of view. So the diverse in AI is very, very vital when we talk about I will so it's almost going to be we have few minutes left, maybe like couple of minutes. Any questions from our audience? Would love to have you. Any question, any last question? Like, I'll love to take one question from our audience if anybody has any question. Okay, if none of you have any questions, I hope
There
you.
is a question in chat. Can you read it?
I think there was discussion, like they were having discussion in the chat. I don't know. I only see everyone, nobody's. So it was a chat discussion. So if not, that's being said, it's okay to finish. We are right on the time. Thank you so much to all of our panelists. It's an honor to moderate all of you and hearing all of your perspective. And thank you so much. We're like grateful for this platform as well. And thank you for giving us an opportunity.
Yes, thank you. Thank you all. This has been a wonderful panel. Let's give them a virtual round of applause. We're very grateful for a terrific panel this morning. And I'll give you let me stop the recording.